Here's an overview of the method that we're going to use to analyze available soil phosphorus. First, we extract or shake the soil in the sodium bicarbonate solution, which is also called Olsen solution. Then, we're going to allow that solution to settle for 10 minutes so that some of the clays settle out to prepare it for filtration. Then we filter the solution. There are two methods for that, and that gets rid of the rest of the clays in the solution, making it a clear solution. Then we neutralize this filtered solution with sodium bisulfate, which reduces its pH and will cause all the bubbles from the bicarbonate to leave. And then we will react that neutralized solution with a reagent package, which will create a blue color in the solution, which we then read using a colorimeter. So we read the blue color value with a colorimeter, and depending on how intense that blue is, we are then able to calculate the available soil phosphorus in the original soil sample. That's the overview, and now we'll see it in detail. The first step in the procedure is to weigh out 2.5 grams of soil, which can be either field moist or more usually air-dried soil. Here I'm going to weigh out 2 samples because I want to show 2 different filtering methods later on in the procedure. The precise weight of soil should be noted down to be used later in calculations, in this case 2.56 grams. Now we add 25 milliliters of Olsen solution, which is half molar sodium bicarbonate adjusted to a pH of 8.5. We add this amount to each tube or bottle with the soil sample inside. After adding the Olsen solution, each bottle should be shaken for 20 minutes. Now the 20 minutes of shaking are over, and we will leave the samples sitting to allow clays to begin to settle from the solution. The bottles or tubes need to settle for 10 minutes. Now we need to filter the soil extract to get rid of any clays that were not removed by settling. We'll describe 2 alternative methods for doing this, and for either of these it may be helpful to build this simple bottle press, which you'll see used in the following video. The next section shows 2 alternative methods for filtering clays out of a soil extract. The first is more fail-safe, but slower, and requires a lab-quality filter. The second is faster and uses cheaper coffee filters, but may become too slow for high clay soils. To begin the first filtering method, we use a plastic pipette to transfer somewhat more than 10 milliliters of solution from the upper part of the bottle to a second bottle for filtering.
we get about 7 mLs. Okay.
In the second method of filtering, we just pour the settled solution into the second filtering bottle with no need to use a transfer pipette. The next step is to use sodium bisulfate to bring the pH of the extracted solution from alkaline to neutral. This will release dissolved bicarbonate as bubbles and will also prepare the solution for reacting with the phosphorus reagent package, which needs a low pH to create a blue color. Next, the neutral solution is made up to a standard volume of 20 milliliters that will create the right amount of extract for reacting with the reagent package. Now it is time for the final step of mixing the neutralized extract with the phosphorus reagent that you have added to the vial already. Note that a second vial without any reagent is also poured, and this is used as a blank for the colorimeter to control for the slight tan color that the soil produces when it is extracted with Olsen solution. Now we'll show how the colorimeter is used to measure the blue color of the solutions in the vials, and thereby how much phosphorus was originally in the soil. The final part of this video explains the calculations needed to find the level of available phosphorus in soil from the colorimeter reading.